Hey guys, in this video we're going to create a Simon memory game console application. Now if you don't remember what the Simon memory game was, it was that circle device that had 4 colors, and throughout time it would say a color and your job was to repeat the color back, but eventually the list of colors would get long where it would be hard to remember the order of the colors. So like I said, our goal is to recreate that in a console application. Now, although I'm using a console application, we're going to be separating the UI and the logic between different classes so that, in theory, you could take the logic that drives this application and move it to any other platform like a desktop application, a website, or a mobile application. And in a future video, maybe I will actually do that as well. Now, this is the first video in my new series that I'm calling Learn C# by Coding, where I'm planning on just building cool applications that are real world like and just going through the code of how I would build it. And I'll start each one of these off by running the completed solution and showing you what the application looks like and giving you an opportunity to pause the video and try to create it on your own and then come back and see how I did it so that this would help you learn. So I'm going to go ahead and start up the solution. And right away you can see 2 things happened. It says round 1 and it said red really quickly and it disappeared after a second, and now it's telling me to type in my color. So remember, this is a memory game and the list is going to grow and grow each round. So if I type in red, I'll pass round 1, and now I'm in round 2, and there will be 2 colors. So it was red, red. So I'll type in red, enter, red, enter. So we have red, red, green, red, red, green, red, red, green, red, 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 green. Now there are 4 possible colors in this game. You could add more if you wanted, but there's 4 possible colors. So red, red, green, red, yellow. Red, red, green, red, yellow. Okay. Now I think that was enough to demonstrate. This will go on and on forever. And that's the reason why this course is about lists. I want to show a list in real world use because arrays aren't practical. An array couldn't work here because we don't know how far the user will get in the game, right? So we need to dynamically grow as the game goes on and on. We're adding to a list to memorize all those colors so that we can check to make sure that the colors that we're entering are correct. So we're using a list. So this is your opportunity now. I'll go ahead and let you pause the video here, and if you want to, you can try this on your own. Otherwise, you could just follow along and I'll show you the solution. And also, one quick thing is if I type in the wrong answer, it just says game over. So keep that in mind on building your own system here. All right, at this point, I'm going to go through the solution of how I developed this, and you can compare it to how you did it, leave feedback, leave comments, and we could talk about it together. So let's go ahead and first think about how we want to separate this UI. So remember, I'm building this in a console application. However, that does not mean that I would have to stay in a console application. In any real world application that you're building, you should always think about reusing your code and splitting your UI up from your business logic. So in this situation, the business logic for our Simon memory game is like the game itself, like what's keeping track of generating those new colors and checking to see if the guess that we typed is correct and so on. What's not part of the game is the UI layer, which is displaying the text, like changing the text to be green when it says green and asking the user to enter a color. That's all UI, and that will be specific per platform, but I should in theory be able to take my business logic and reuse it across any application, whether it's a desktop, mobile, website, whatever I want to do. I should be able to use that same C# logic. And like I said, I may do that in a future video. But for now, we'll stick with console just to keep it simple. So let's build that backend logic. Let's start with building a class called the Simon game. And this is like sort of like our game engine. So I'm in a new class, we'll call it Simon game. This class is responsible for keeping track of the entire game. And how I designed it, I have I have two properties and one private field. So my first property is a public bool that's going to keep track of whether or not we lost. So this is keeping track of if the game is over or not. So I'll make this a private set, meaning that no one who has access to this class could set it to false and break my game. Only this class itself can set it to false. And I'll default the value to false. Now I also have a list. Now the list is going to be responsible for keeping track of the order of colors. And every time we get to a new round, I'm going to add the new color to that list. Now, I could create that list to be like a list of integers, for example, and say that 0 is green, 1 is red, and so on. But I think a better solution to that is to create an enumeration. By creating an enumeration, this makes it a lot easier for anyone that's using this class to understand what that list has, and to interact with this class. It makes more sense. It's more user-friendly to have an enumeration, which behind the scenes is just integers anyway. So I'm going to go ahead and make an enumeration in a separate file. Unfortunately, in Visual Studio, there's no file template for that. So you're going to go to File, you're going to go right-click, go to Add New Item, and you'll go to Class, and I'll just call the class Colors. And I'll change class to enumeration. So I'll just say public enum instead. So now I have my enumeration, and in my enumeration, I'll have green, red, blue, and yellow. These are the possible colors that our game are supporting. We could change this if we wanted to add more colors, which in turn would make the game more difficult. Okay, so now that I have my colors, let's hop back to the game engine. And let's create a list of that. So I'll say public list, and in the generic parameter, I'll pass in colors, saying this is a list of colors, and I'll call this colors, and once again, I'll say get private set. Okay. And the last field that I have is a field that is going to keep track of my guess position. So what that means is that as I'm making guesses in my program, this is going to keep track of what guess position I'm at. So for example, if it's round 1, it's going to say, okay, the guess position is 0, which means in the list, I'm checking my guess against the position 0 in the list. If there were 5 elements in the list, let's say we're on round 5, and guess position could be 2, that means I should be checking the 3rd element in the colors list to compare against whatever was typed in for the guess. You'll see what I mean by that as we build the code out for it. Okay. Now, we could just instantiate colors directly here, or we could make a constructor, because we need the constructor anyway. So I'll just create a constructor called Simon Game, and inside my constructor, I'll say colors equals new list of colors, and I'll also need to generate my first color, because right when you create an instance of Simon Game, I want the game to start. So I'll generate my first color. That's why right when the program starts, it says green or yellow. So we need to somehow generate a random color. So let's create a method, a private method. This is a helper method for this Simon class to help generate random colors. So I'll say private void generates random color. I'll just change this to generate color. And in my generate color method, I'm going to use the random class. So I'll say random ran equals new random. This is a class to generate random numbers. Then I'll say int random color as an integer, because the random class only returns integers. And I want to return a number that's between, or a number that has a possibility of 4 different numbers. So 0, 1, 2, or 3. And if you use the next method, you can see there are different parameters to it. I'm going to use this version, next int max value. And if you read the description, it says the exclusive upper bound of the random number to be generated. So if I typed in 4 here, since it's exclusive, it will not ever pick 4 as a random number. But 0 is a possible number. So it will generate numbers between 0 and 3. 0, 1, 2, or 3. So as you can see, I designed this to work with my enumeration, because in my enumeration, there are 4 colors. Green is 0. As you can see, it says 0. Red is 1. Blue is 2. And yellow is 3. So once I have this integer that's random, I can then just take that integer and convert it right into a color by casting it. So I can say colors, which is my enumeration, colors random color equals colors, oh, this should be ran color as int. So this will take the random color as int that was generated for us, convert it into a color enumeration value, and then I have that color value. So the last thing we need to do is let's just add it to our list. So we'll say colors.add ran color. Now remember, colors represents the list that we designed up here. It keeps track of all of the computer color guesses, or all the computer generated colors in their list. This is basically the rounds of the game. Great. So now every time I call generate color, it will add a new color to my list, which means it has to be guessed by the user. So in my constructor, when the game starts, I'll go ahead and I'll call generate color. Okay. Now, really the last thing we have to do for the logic of the game is to basically build the method to allow the person to take a guess. So I'll go ahead and make a method called public bool make guess, and they'll pass in a color. Right? So it would be like green, yellow, blue, and then it says, okay, make a guess. So I'll then enter green, yellow, blue. But each make guess call represents a single turn in that queue. Meaning when you have, let's say we're on round 3 and there are 3 colors, you will call make guess 3 different times for that specific round. So for every round, you'll call make guess the amount of times that there are colors in the list. That's how I designed it. So inside of here, I'll say if colors sub guess position, this is where that guess position comes in, I'll explain it, is not equal to color. Okay, let me explain that. So what this is saying is the color that they're guessing for this position, it has to match the color in that list. So guess position is the current position that we are in on that round. So for example, if we're on round 2 and you're about to enter the first color of round 2, guess position would be 0. So I'm saying, okay, is colors sub 0, the first color in the list, not equal to the color that they typed in? If that's the case, then we know we lost the game already, because if we don't have a match, the game's over. So I'll say game over equals true, and I'll return from this method by saying return false. So that's one part of it. Now, if we say else, that means that whatever color that they typed in, it was the correct color. So they guessed the correct color. Now, we need to make sure if they're guessing the correct color, there's another condition. Well, is the round over? Meaning if there are 5 colors and I guessed the color correctly, was that the last color in that round? If it was, I need to say go to the next round. So what I'll say is if guess position equals colors dot count minus 1. So what this says is if the guess position that I'm currently on, so if this is, for example, round 2, and guess position is equal to 1, which means the second guess, right? Because the first guess is 0, the second guess is 1. So if I'm on my second guess, that should mean the round's over. So I say if 1 equals colors.count, well, that would be 2 if we're on round 2, minus 1. So remember, count returns the amount of elements, whereas guess position is the position in the list. So I want to minus 1 because we start at 0 for positions. Okay, so if guess position equals colors.count minus 1, that means that the round is over. So let me just go ahead and add that. Round over. And if the round's over, I want to reset my guess position back to 0. That's what signifies a new round, that we're at the beginning of the list again. So the next time we call make guess, it's going to check the color in the beginning of the list. Okay, also, if the round's over, we need to add a new color to the end of the list for the next round. So I'll call generate color again, and then we'll say return false, meaning that we did not lose, or sorry, meaning that this guess is over. That's what it means. And then if we're not in this if statement, meaning the round's not over, but our guess was correct, right? Because this else section represents our guess is correct. This means our guess is correct and the round is over, meaning it was the last guess. But if I'm right here, that means that the guess was correct, but the round is not over. So in here, I'll say guess position plus plus, return true. So by returning true, that means the round's not over and you need to keep on guessing. Return false means that you can stop guessing because either it was the last guess in the round or you lost. But return true means keep on guessing. And that's why I make guess position plus plus. So every time I get a successful guess that's not the end of the round, I say increase our guess position so that next time we'll guess for the next number in the list. All right, so with that is all of our logic to drive this entire Simon game. Believe it or not, this is everything to make a Simon game, and I'll walk through it when we do it. But let's head back to program because now we need to build the UI. And the UI is going to consist of a couple of things. So let's start by just creating an instance of our Simon game. So Simon game equals new Simon game. And we want to loop for as long as our game is not over. So game over. So while the game is not over, we want to keep on running. So as long as we're in the game, let's keep on running. And then every time the game runs or loops in there, we'll say enter. Well, actually, before that, let's hold on a second. So once we get into the while loop saying the game is not over, we need to display our current round, right? We need to say it's round 1, and then we need to display the colors, so red, blue, green, or whatever they currently are. So we need to build some kind of method that's going to use our assignment class to go ahead and pull that information out and display it to the user and color coordinate it and everything like that. Now, it would be very easy for me to mistakenly put that logic into the Simon game, right? I could easily put it in here and say display current round. But that's a bad idea because that would then make this code not reusable across my platform. So I don't want to do that. I want to make sure all of my UI code is forced to be inside of the UI stuff, which is the main method here, or the program class. But in a Windows Forms application, I would put that in a Forms class, for example. So let's make a private method, private static void display current round. And this will do two things. It's going to display the current round and then also the colors in that round. And the reason why I'm making it static is because main is static. So if I want to access that method, it needs to be static as well. Okay. So let's start off with just clearing the console. And that's because every single time this method runs, it's going to go ahead and run and say the current round and the colors in that round. So when I start, I want to make sure it's a fresh screen so you don't see the previous guesses, because we need to make sure those colors are constantly going away because they could just use it to cheat to know the order. Then I'll say for each colors color in game.colors. So remember, the game colors list represents all of the rounds, or not the rounds, but it represents all the colors in the game. So we're going to go through that because we need to print each color to the user one by one. So we'll first say, okay, let's print the round. So we'll say round, and then we'll plug in the round that we're on. So we'll say game colors count. Or sorry, yeah, count. And then I'll also just add a new line there. So there's two new lines. So this means when, for example, if I'm on round 1, that means there's one color in the list. So when I run this, it will say round 1. And then after round 1, I want to display the color, but I want to wait a second. So I can use a method called system threading thread sleep 1000. That means freeze the current thread for 1 second. So I display round 1, I wait 1 second, and then I'm going to display the color. Now, I can just simply say console.writeLine color, and that will print out whatever the color is. That works just fine. But to color coordinate it and say, if the color is green, to make the console color green, you need to add a switch statement here to tell it what to do in those situations. So if you don't want to color coordinate it, you don't have to, and it makes this code a lot more simple. But I think color coordinating is a lot more fun in the game. It makes it more realistic. So I'm gonna say switch color, and then I'll right click on color and I'll say quick actions. If it would work. Let's go over here. So if you go to the switch color, you see the little lightning bolt. You can click there for quick actions, and you want to hit add missing cases. You can also, if you have color selected, you can hit control period, and that will bring that up. And if you hit add missing cases, that will just add a switch statement with all of the possible values in the enumeration, which is green, red, blue, and yellow. So I'm going to say, if the color is green, let's make the console green. So I'll say console.foreground color equals console color.green. And I'll do this for each. Let me just copy that code. Copy, paste, paste. Let me remove these lines. All right, so if it's red, I'll make the console red. If it's blue, I'll make the console blue. And if it's yellow, I'll make the console yellow. So at this point, I am displaying the color and the text. So after I display the color, though, I want it to display the color for a second and then make it go away. So in that case, I have to do another sleep. So I'll copy that code. I'll add another sleep. And then after that 1 second, I need to make sure it goes away. So I'll say console.clear again. And that will make it go away so they can't see the answer. The one last thing you should do is you need to reset the color, because with a console, when you set the console foreground color, it will stay that color forever after that point. But we don't want that. We want it to go back. So I'll say console reset color here as well. And then finally, there's one last piece I need to do, and that is I want to display the round count one last time down here, because this is going to prepare it for the next round. So while it basically, when it's asking you to enter in your color, we want it to say round still. But remember, I just cleared it. So after the last clear to hide the colors, I want to then say round 1 again, and then enter your color so that you know what round you're on while you're entering the color. And it's a little bit confusing because you haven't tested this, but I just figured this all out by running the application and seeing what looked good, and I just went back and modified it. So if you want to do that as well, by all means, go ahead and do it. But now I have the logic to display the colors. So right when the game starts, I'll say display the current round, and I'll pass in my game to do that. That's the reason why this takes in-game as a parameter, so I can pass it in so it has all the information about the game. Okay. Now I'm going to do a do-while loop. Now, the reason why I have to do a do-while loop is because this outer loop is responsible for keeping the game going, but then this loop is responsible for asking me to enter a color for each color in that specific round. So if I'm on round 5, remember I type in 5 different numbers. Those 5 different numbers are being asked of me by this loop. This is the round loop. This is the game loop. So in here, I'll say console.writeLine, enter color. Okay. Then I'll get their color. So I'll say string color as string equals console.readLine. So whatever the color they type in, let me store it. But remember, when I make a guess in my make guess method, it takes in a color, not a string. We're getting a string from them, but we need a color. So we need some kind of way to convert from string to color. And there's many ways we could do this, but the cleanest and most organized way is to create a class, a static class that's responsible for this conversion. So I'll say new item, I'll create a new class, and I'll say string to color converter. Okay. And in my string to color converter, it's pretty simple. It's going to be a public static class, and I'll have a public static method that returns a color called convert, and it takes in a string as a color, or takes a color as a string. And our job is to basically just switch on that color. So I'll say switch color to lower, meaning if they type in an uppercase color, I'll just convert it to lower so that I can compare it here. And then I'll add my cases for each. So I'll say case yellow, and I'll just copy and paste this 2, 3, 4. So we have yellow, blue, green, red. So these are as strings, and I'll convert back to the enumeration. So instead of break, I'll say return colors yellow, return colors blue, return colors green, and return colors red. Now, there's one problem with this, and that is the colors method, or the colors enumeration, only has 4 possible values, and the convert method needs to return a possible value. But if and the convert method needs to return a possible value in each situation. As you can see, we're missing a clause. Like, what happens if, none of these are true? We need that default case that says, in a default situation, return something. But we can't return a color, because if we return a color, the game will think that we made the right guess, or made a valid guess, even though it may not be a valid guess. If I typed in purple, but I have to return red, red could be the right answer, but you typed in purple. So I'm going to add a default case, and in my default case, I'm going to return something that's unknown. So I'm going to return colors.unknown. Now that isn't a value yet, so I'm going to go ahead and add that into my colors enumeration. I'm just going to add one last value called unknown, which means the guess that they took is just unknown. We don't know the answer here. I spell wrong. Unknown. And there you go. Now the convert method is working as expected. So going back to my game, or sorry, my program.cs, I want to be able to convert this color as a string into a color. So if I say color equals string to color converter, convert, it wants the string, so I'll say color as string. Now we'll have a color. And then I need to simply pass this into game.makeGuess. Remember, that takes in a color. But remember, makeGuess returns a bool. Let's refresh it. Remember, if return guess returns false, it means either the game is over or the round's over. If it returns true, that means it needs to keep on going on because you're still in that round. So if this is the round loop, I want to keep on doing this while it's true, while I'm in that round. As the method returns true, I want to keep on doing this, asking for more colors. So I'll move this into the while. I'll say while that's happening, then do it. Now it's just telling me that I can't access colors, so let's just move colors up a level of scope into there, and then I'll say color equals here. Okay, so I asked them, so the game starts, displays the current round and all the colors. Then it says enter a color, starts the round loop. I read in the color, convert it to a color, and I say, is this the color? If it says true, that means yes, it is, but there's still more in the round. So I go back, do it again, do it again, do it again. Eventually, this will return false. And it could return false in 2 situations. It could say if you made the wrong guess, or if the round's over. So if this returns false for the round's over, but it was the correct guess, this returns false, so this loop breaks out. It comes to this outer loop and it says, is the game over? And it goes, no, the game's not over. It's still going. Oh, okay. Display the next round. However, if this returned false and the game was over, it would come here and say, no, the game is over. And then it would break out of that loop. And then we'll say game over here. Remember, because in the make guess method, we mark game over to true when they make the wrong guess. So using this logic, you could take this logic and build a mobile Simon Says or Simon memory game. You could build a website. You could build anything you want. Here's the logic, and then this is just the UI stuff. So we split them up. This is a good programming practice. But just like that, if I go ahead and run the application, we have built a Simon game. So round 1, it said green, enter color, green. Round 2, green, 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 green. Let's do one more round. Green, green, blue, green, green, blue. And I'm just going to stop it there. So there you have it. We just built a Simon memory game that is loosely coupled and separated between UI and backend logic so that you can move this to any platform and make a Simon game on any platform that you wish.